Alright guys, so let's start with states of matter and atomic structure. So we've got two pictures here on our title page. One is the dinosaur, which is kind of wrong. I hope that you can find the mistake in that picture. It's probably going to be one of your warm-ups. And then in the bottom right-hand picture, there are the three basic states of matter: the solids, liquids, and gases. And then what makes those, it's got some examples of them there. There's a link here at the bottom. I'm going to include that in the annotation at the bottom of the picture. I'm sorry, of the notes link, so you can go back and visit this. But hopefully you remember what makes the three states different from 6th grade. If not, we're going to cover it, but really quickly. So first, let's define a particle. The definition, according to the dictionary, is that it is a minute portion, a piece, a fragment, or amount, a tiny or very small bit, a particle of dust, not a particle of supporting evidence. So we're going to look at that part of the definition, and we're going to look at what is the piece or a fragment. We're not going to look at so much the minute portions or amount of. We're going to focus on the piece or fragment. So today we're going to look at some super tiny small pieces of matter, a particle of matter. This can include parts of our table, water droplets, even parts of our atoms. So a particle is just parts of little tiny pieces or fragments. So the first particle we're going to look at is a gas particle. So you're going to draw this area up here, this top circle, which is a gas molecule. So we're going to look at gas particles. Are very well separated. They have no regular shape. They kind of vibrate or shake and move freely. They move at extremely high speeds. They're compressible, which means that they can be squished into spaces or fill up a space. There's lots of space in between the gas particles. So if you saw this red dot here, this is a red gas. It's a gas particle. So if you notice, there's lots of space around it. The gas particles tend to move or slide past each other very, very easily. So in your notes with the next 3 slides, because they're gases, solids, and liquids, you need to include the drawing of what it looks like, the word itself, and then these are going to be your main points. They assumes the shape and the volume of the container, the particles move past one another, etc. All right, so liquids. The particles in liquids, if you notice in the picture, which we're drawing, right? They're close together, but there's movement in between them. Liquids have no regular shape. The particles vibrate and move past each other, but slower. They're not easily compressed. If you've ever held a water balloon, if you blow up a regular balloon and then you fill up the same size balloon with the same amount of water, you can squeeze the air balloon a lot more before it pops versus the water balloon. They're considered a shapeshifter, which if you pour water from the water hose into a swimming pool, into a cup of water, like that water will take on whatever shape it has. Which takes us to this next part. They take on the shape of the containers. And the particles do move past each other, but it's more confined. They can't race past each other. They kind of have to slide and slip past each other. So again, you may have to pause it to get the boxes down here on the side. And then the last one is solids. The solids, if you look at the picture, they're very tightly and more rigidly packed together. They do have a definite shape and a definite size and amount of space that they take up. Solid particles, they vibrate, but they don't move, and they're kind of stuck in their place, in their spacing. So it would be like if you were in a really crowded elevator, you can still move, but you can't move around like if you were the only one in there or if there were only 2 people in there. Solid particles are locked into place. They are not easily, if at all, compressible. There's little free space between the particles. And then this word down here, rigid, if you don't know what it means that it's hard or solid. You may have to look it up if you don't know. So the rigid particles don't move or slide past each other. They are stuck in place. So then this link will also be in the descriptions below, and I think it's a brain pop video about like atomic structure. So these notes, if you're in class, will be given to you on a piece of notebook paper. They're photocopied for you, so you just have to fill them in. But looking at the atoms, so we have a nail here and then a blowout of the iron atoms that make up the parts of the nail. So an atom is the smallest particle, and there are 3 basic parts to the atomic structure. So you're going to draw this piece here, this little, this is a really simple hydrogen atom for you to look at. And then the 3 parts are the electron, the proton, and the neutron. So let's dive into those 3 pieces a little deeper. If you want to write your notes in this form, in this big box up here with the symbols, that's fine. Or if you want to do it like it's down here in the bottom picture, that's also fine. It's going to be up to you how you want to design your notes. So let's start with a neutron. A neutron is neutral, and it's large. There's 2 big pieces of the atom, this proton and the neutron. So the neutron is one of the largest pieces in the atomic structure, and it's neutral, which means it has no charge. The proton is the positive charge in the atom, and it is also large. So between the protons and the neutrons, if you look at the picture up here on the right, they make up the nucleus, and they make up most of the mass of that atomic structure. And then the electron is small. It's very, very tiny compared to the other 2, and it has a negative charge, and it moves very quickly around the outer shell of the nucleus. So what is in the nucleus? So the nucleus is at the center of the atom. Hopefully you remember that. It has almost all of the mass. So if you looked at the periodic table and you look at like lithium, its atomic mass is 6.99 something. So we round that up to 7. So that 6 point is the atomic nucleus, and then the 0.99 is all of the electrons on the outside. And then it contains both the protons and the neutrons. And I give you this picture down here because most of you guys remember from 6th grade and then from 7th grade too, with the nucleus of a cell and how that's kind of the central piece. And there's 2 parts to the nucleus. There's also 2 parts to the nucleus in the atomic structure. There's the protons, positive, and the neutrons, neutral. So what do you think makes up most of the atom's mass? Well, we just said that. It's most of the nucleus of an atom is the mass of that atom. It's because the protons and the neutrons are so much larger than the electrons. And if you see the picture over here on the right, you can see that the neutrons are a little bit smaller than the protons, not by much, but then the electrons are much smaller. So protons, let's look at what is a proton. A proton is located in the nucleus. It determines what the element is. So if I know how many protons are in an atomic structure, I can then tell what the atom is, and then that will tell me what the element is. So the protons are actually the atomic number on the periodic table, and it has a positive charge. So protons, positive, that one's pretty easy. The alliteration is there, the P and the P. So neutrons, if you don't know, I really enjoy watching Futurama. This will be its last season, so I'm kind of sad. So I remember the neutrons with the neutral planet, where one of the Nimbus is about to fly into the neutral planet, and this is their ruler, and he says, "If I don't survive, tell my wife hello." That's kind of odd. It's very neutral, no feelings to it. And then here, when they're about to go into battle with the little pink guys who are trying to steal all the information, it says, "I have no strong feelings one way or another." So the neutrons are in the nucleus, and they have no charge. They are neutral. So if you look here, neutron starts the same as neutral. And then these guys can vary from atom to atom. within the same element. So an element of carbon may have, it always has the same number of protons. A carbon atom will always have 6 protons, but it could have 6 neutrons, it could have 5 neutrons. In this word isotope, there's some more videos that I made that we will go over towards the end of the year about what is an isotope and why is it important. So if you can remember the neutron is neutral, like the neutral planet, and you'll be good to go. So the electrons, I like green, so yeah. What do Shrek and electrons have in common with an onion? So that's like the weird question for this page. Electrons have a negative charge. They are located around the nucleus. They are not in the nucleus. And then there are 3 shells. For what we do in 8th grade, we only go up through the top 18 elements on the periodic table. Those are the ones you have to know, like all the ins and outs to. So there's 3 shells, and they hold 2, 8, and 8. It says 18 here. As you get farther up into the different elements, the 3rd shell can hold up to 18. But for what the 8th grade knows, it's 2, 8, and 8. So the Shrek, electron, and onions all have shells that make them complex, or layers that make them complex. So let's look at valence electrons. Our valence electrons are the electrons on the outermost shell. So they're the 2 red dots here on this atom of Einsteinium. And they are the ones that are available for bonding and what elements can kind of like link up together. So the definition, they are electrons in the outermost shell or energy level or even orbit, depending on what the test or the text you're looking at says. So there are electrons on the outermost shell, and they're the ones available for bonding. So the key points for today, atoms always have atoms usually have a neutral charge, meaning their protons and electrons are the same number, which means it gives them an overall net charge of 0. So if you look down here on the bottom right, 7 electrons, that's a negative charge, and 7 protons, which is a positive charge. So if I have 7 positives and 7 negatives, they cancel each other out, making a neutral overall charge. Most of the mass is located within the nucleus because of our protons and our neutrons, and atoms connect together to make molecules. So hopefully you can label these. In your notes, I would do a rough sketch of these. So these 2 colors in here, there's 2 options. There's 2 possible answers for each one, and then hopefully you get this one right by itself. And then this is also in your notes, and you'll need to complete this Venn diagram. You'll probably need to look at the brain pop on solids, liquids, and gases if you can't remember enough to fill this in. And then lastly, these are your vocabs for this week. So solids, protons, neutrons, electrons, valence electrons, and gases. So you'll need to make your vocab study guide somehow. So that's it for this. I hope you enjoyed it. Please go back and review as many times as you need, and I will see you in the halls.